And in 1-3, the first part of 1-3, we're going to review a little bit about square roots and how square roots work. So we're going to review square roots. Now, how do square roots work? Well, an easy one to look at is the square root of 16. And we know that the square root of 16 is 4, right? We know that. Now, why is it 4? Well, if we take our 16 and we break it down, what does 16 break down into? 4 and 4. Okay? And anytime we break it down, if we have a pair, the pair comes out as 1. So the square root of 16 is 4 because 16 breaks up into 4 squared. Same thing with the square root of 25. Square root of 25 is simply 5 because 25 is 5 squared, right? Where it becomes a little bit different is when we have something left over. Because not everything is a perfect square. So we'll start off with a really easy one. Let's look at 12. Okay, let's try to find the square root of 12. Well, first off, is 12 a perfect square? No. What we need to do is we need to factor down and break up 12. And we're looking for pairs. So we're going to take our 12, and we're going to break that 12 down into 4 and 3. Now, our goal is to get pairs of numbers. 3 can't be broken down anymore, but 4 can be broken down into 2 and 2. Now, we want pairs, and whenever we have a pair, the pair is going to come out. So for the square root of 12, we're going to break that down into 2, and that 2 is out in front, right here. And then what we have left over is 3, because 3 had nothing else to go with it, right? So the 3 just comes along with it. So when we break up these roots, what we do is we look for pairs, and anything that doesn't have a pair and won't break down any further is just left inside. So let's try the square root of, how about 50? Here's another easy one, square root of 50. How does 50 break down? And there's different ways of breaking it down. I'm going to break it up into 2 and 25. And I did that because I know that 25 is a perfect square of 5. So the 5s are going to come out in front. And you only write them once, so it comes out in front. And what's left over? Square root of 2 on the inside. Okay, let's try another one. How about the square root of 80? Same process. We take our 80 and we break 80 down. And you can break it down a variety of different ways. Doesn't matter how you want to break it down. I'm just going to break that down into 8 and 10 because 80 ends in a 0. And 8, we can break that down into 2 and 4. And 10, we can break that down into 2 and 5. And then 4 can be broken down into 2 and 2. So now let's see what we've got. We've got a pair of 2's here. So there's one pair. And we have another pair of 2's right here. And what isn't paired up? The 5. So when we have the pairs come out. And if we have multiple pairs, the pairs are going to be multiplied together. So we've got a 2. We've got another 2. And what's left over that didn't have a pair? 5. And we multiply our 2's together because they're the pairs. And that comes out to be 4 square root of 5. Let's try one more of these. And then we'll talk about imaginary numbers, in complex numbers. Let's try one more. How about we try the square root of 150? Okay, so let's try 150. And again, you can break these up however you want to. 150 ends in a 0, so I'm going to go ahead and use a 15 and a 10. Easy enough there. And 15, we can break that down into 3 and 5. And 10, we can break that up into 2 and 5. I picked this one on purpose because we're going to have to work with the roots a little bit differently because they're going to multiply as well. Let's find our pairs. What do we have? We have a pair of 5s. So that pair of 5s comes out in front. And what's left over? Well, what doesn't have a pair? In this case, there's two numbers that don't have a pair because we've got a 3 and we've got a 2. So they go inside that square root, and they're going to get multiplied together. So whatever's left over, multiply it together. And then what's my final answer going to be? 5 square root of 6. That's going to be your final answer there. And you may or may not have worked with roots in your intermediate algebra course. Some instructors cover them. I really don't cover roots much. I wait and cover them in college algebra, but you may have had them before. But what you haven't had is this. If I gave you this, let's say I gave you the square root of minus 25. Now, square root of minus 25 in intermediate algebra, you would say that this is not a real number. So from intermediate algebra, you would just say, that's not a real number, and we would move on. Now in college algebra, we have to work with that. It's not a real number, but it is something. Okay, well, what is it? It's going to be what's called a complex number, and it has an imaginary component. So we need a new definition. And there's only two definitions in this section. And our first definition is I. I is defined to be the square root of a negative 1. And I just stands for imaginary. So I is just going to stand for imaginary. So these numbers are not going to be real when they have a negative inside. They're going to be imaginary. So how is that going to work when we have square roots? Well, if there's a negative underneath, it's going to work the same way, but we just bring out an I. So if I gave you, let's say, the square root of minus 25, now we know the square root of 25 is 5, right? We learned that before. So we just bring that out as a 5, and because it's negative underneath, we simply bring out an I. So the square root of a negative 25 would simply be 5i. That's it. It's imaginary. And in previous courses, you would have just said that's not a real number and moved on. In this class, though, we have to account for it, and we call that imaginary. Let's do two more of these. Let's look at the square root of minus 216. So minus 216. We're going to go ahead and take our 216 and we're going to break it down. Now again, you can break down 216 however you would like. It is an even number, so I'm just going to go ahead and work with a 2. So that's going to be a 2 and a 108. And 108 is another even number, so I'll use 2 again. 2 and 54. 2 and 27. 3 and 9. 3 and 3. Okay, so this one's a little bit more challenging as far as breaking it down. We've broken it down as far as we can. Now we want our pairs. So let's see how many pairs we've got and what they are. So we have a pair of 2s, and we have another pair of 3s. So we're going to have a 2 that comes out, a 3 that comes out. We are also, because of the negative here, going to put in an I. And we bring the I out in front of the root. And what's left over underneath the root that's not paired up? So what didn't get circled? 3 and a 2. So those get multiplied together. And now we can finish it. 3 times 2 is 6. The I is in front. Make sure that I is in front of the root. And 2 times 3 is a 6 inside. So the square root of a minus 216 is 6i square root of 6. Just to make sure we understand the difference of where the negative is at, let's say I put the negative in front. And we'll just do a really, really easy one here. What about a negative in front of the square root of 100? Now, if the negative is inside, it's imaginary. If the negative is out in front, it just comes along with it. So we know that the square root of 100 is 10. And the negative is out in front, so all that does is come along with it. And so what's my final answer? Simply negative 10. That's it. It's not imaginary. Why not? Because the negative is out in front. Also, you cannot cancel negatives. So if a negative is in front and underneath the root, they will not cancel out. So let's try this one. You cannot cancel out the negatives. Why not? Because you have to do the square root before you cancel. Because when you cancel, that's multiplication. And square roots are always done before multiplication. Break up the 18. 2 and 9. 3 and 3. Got our pairs. So let's see what we've got. We've got a 3. Now, in front of that 3, we have a negative here out in front. So that 3 becomes negative because of the out in front negative. And then we have an I. Why do we have an I? Because the negative inside, right? Makes it there. And then what is left over that doesn't have a pair? 2. So that is minus 3i square root of 2. So that's a little bit of a review about how to work with square roots and imaginary numbers. Now let's talk about these new types of numbers. And these new types of numbers are going to be called complex numbers. So remember, in previous courses, we only work with real numbers. Right? We didn't do anything with imaginary components. When we add in the imaginary components, we get what are called complex numbers. And complex numbers look like a plus bi. And they have a real part in front, and they have an imaginary part. So they have a real part, and they have an imaginary part. Let's look at some examples of complex numbers. How about 5 minus 3i? That's a complex number. 8 minus 2i. Again, complex number. And 9 plus 16i. Complex number. They have a real part, and they have an imaginary part. And now we're going to classify numbers. So we're going to add some new classifications. When we classify numbers, we start at the very top. At the very top, we have what are called complex numbers. And all numbers are complex. So they may or may not have a real part and an imaginary part, both, but all numbers, every number is complex. So these are all going to be complex numbers. 5 minus 8 plus 2i, complex number. 9i. 10 plus 7i. Every number that we have worked with is complex. It doesn't matter whether it's got a real part, an imaginary part only, or both. Everything that we work with is now considered complex. Used to, we called them real, but now we have another level, and that's called complex. And then we have real from here and non-real. So all numbers are complex. Now we'll look at the real numbers. And real numbers have no imaginary component. So these are not going to have any imaginary component. And this is what we've been working with in all of your previous math courses. Remember, every number was real, right? With the exception of division by 0, what we called everything real. And so 9, that's a real number. A half, that's a real number. 8, that's a real number. Minus 1.3, that's a real number. Pi, that's a real number. 4, that's a real number. Every number that doesn't have an imaginary component is real. All the numbers we work with in all of our previous courses, they have always been considered real. If they're not real, we call them non-real complex. And non-real complex, they have an imaginary part. And so these are all going to be examples of non-real complex numbers. Five plus 4. That's non-real complex because it has an imaginary component. Minus 3 minus 8i has an imaginary component. 9i minus 14i. All of those listed out are non-real complex. They can have a real part and they can have an imaginary part, or they might just have an imaginary part by themselves. We've got one more classification to look at, and then I'm going to draw you a tree diagram so you can see how we classify numbers. The last one is going to be pure imaginary. So when we talk about pure imaginary numbers, these numbers only have an imaginary part. So these numbers are only going to have an imaginary part. And here's some examples of pure imaginary. 5i minus 12i, 3i. Those are called pure imaginary, because they do not have a real component. Now, when we go to classify these numbers, they're going to be more than one type. Just like an animal, we classify an animal. You've got broad definitions of animals. It might be a bird, it might be a reptile, it might be an amphibian, right? But they're all animals. So the animals can get broken down into different parts. Same concept here. When we look at these, the very first type that we're going to encounter is complex numbers. Every number is a complex number. So it doesn't matter what it is, it's complex. So we're going to start with the complex numbers. And then we break down the complex numbers into one of two types: real or non-real complex. And then we break the complex numbers, because real numbers we're not going to break down any further. But the non-real complex numbers, we can break them down one step further. And we can break them down into what are called pure imaginary. So now we're going to classify some numbers here. And they're going to be more than one type. So when we classify numbers, they're always going to be at least two types. They might be three, but at least two types. So we're going to try to classify the following, or identify the following. So let's just say I want to classify 5. Well, now, when we look at these numbers, the first thing we do is we ask ourselves this simple question. When we look at 5, is 5 real or non-real? It's real. Okay, now we follow the tree up. So if it's real, it's also going to be a complex number. So 5 would be real and also complex. Every number is complex. What about 8 minus 10i? Well, 8 minus 10i, is that real or non-real? Non-real. Is it pure imaginary? No, because it has a real component with that 8. So this is non-real complex, and is also a complex number. So it's non-real complex, and it's also complex. If it has a square root, you may have to break it up. So let's look at the square root of a negative 4. Okay. Where's the negative located at? Inside. What's the square root of 4? 2. What comes along with it? The I. So that would be 2i. Now, what is 2i? Is 2i real or non-real? Non-real. Is 2i pure imaginary? Yes. So now it's 3 types. So it's pure imaginary, following the tree up. It's also non-real complex, and it's also complex at the very end, because all numbers are complex. So it's all 3. Pure imaginary, non-real complex, and also complex. Now we're going to talk about how to multiply and divide these imaginary numbers. And then we'll look at standard form. Now, one thing that we need to remember, and this is the second definition that we need for this section, and it's very easy to work with, is the fact that I squared is a negative 1. So whenever we have an I squared, it's going to get replaced with a negative 1. And this is just a definition that we need to make sure we remember. So when we go to multiply square roots together, we always break them up first, as far as we can go. And then anytime we have an I squared, we're going to replace that with a negative 1. And we'll just do a couple of these, just so we can do the important part, which is the standard form. So we'll just do 2, maybe 3 of these, and then we're going to focus the last part of this lecture on standard form. So let's go ahead and multiply these square roots together. And let's say I just give you the square root of minus 9 times the square root of minus 13. Now I gave you 13 because not all square roots are going to break down. Okay? It may or may not break down at all. 13 happens to be a prime number. It's not going to break down at all. And sometimes you'll encounter square roots that just will not break down. 13 has no pairs in it. Now what about the square root of negative 9? Okay, well, the square root of negative 9, that is 3i, right? Okay, so square root of 9 is 3, so that comes out. Negative drops down behind it as an I. What about the square root of 13? Square root of 13 will not break down. Now it is negative, so we have an I, and we put the I in front of the root. The normal writing convention on the imaginary part is it is behind the number and in front of the root. So that's normally where we place them. They're going to go in front of the root and behind the number. And now when we multiply these together, the 3's out in front. I times I is an I squared. And the square root of 13 just stays with it. And what do we know about I squared now? What's our definition say? It says that I squared is a negative 1. So our final answer would simply be then minus 3 square root of 13. And that's the only place where students sometimes get confused, is you have to remember the i's multiply together. Now, everything out in front goes together. Everything underneath the root goes together. But you cannot multiply the 3 times the 13. They're separate. One's out in front, one's underneath the root. Let's try one where we've got to break it up, and then we'll look at division. Here's another one for us to look at. What about 20? Okay, 20 is going to break down a bit. Let's see how we can break up 20. So 20, you can break it up different ways. We can break this down into 4 and 5. And then the 4 can break down into 2 and 2. So the 2's here are going to come out. So that's going to come out. The negative underneath this root comes down as an I. And what's left over? 5 doesn't have a pair, so that's the square root of 5 left over. So there's that piece. What about 18? 18 you can break up different ways. I'm going to make it easy. 2 and 9. 9's a perfect square of 3 and 3. These are not difficult, it's just new. But square roots are actually pretty easy to work with. So that's going to be a 3 square root of 2. Why do I not have an I? Well, this one's a positive 18, isn't it? So there's no I with it. Now we multiply. 2 times 3 makes it 6. We have a single I, so that stays there. So just multiply these together. What about underneath the root? What's going to be underneath the root? 10. Why is it a 10 underneath the root? Because that comes from 5 times 2, which is the 10. So you multiply what's out in front. 2 times 3 makes it the 6. So that's the piece out in front. Whatever's underneath the roots, those multiply together. There's no I squared because there's just one I, so it stays as a 6I square root of 10. So that would be your final answer on that. So if I gave you those two to multiply together, that's what it would come out to be.
So what happened to the 10? I guess I'm confused.
Okay, which part now?
Well, I see the 6I and
Okay,
the 10.
so we got these two here. So we need to multiply these together.
Okay.
So 2 times 3, that makes it the 6,
Right.
right? The I came down because there's a single I, and that 10 came from the 5 times the 2.
And so when we break it down, it's just not there anymore?
Well, this is your final answer here, because that 10 is still, yep, that 10.
I assumed that 2 and 3
Yep.
was 6.
Okay, I was right with you.
Does it make sense now?
Yes.
You do
This is all imaginary.
You do the numbers out in front, they go together. You do the numbers underneath the root, they go together. They're separate. So 2 times 3 makes it 6. 5 times 2 makes it 10. Now does it make sense?
Yes.
Yep.
That
And
makes
that's
sense
why I
now.
labeled them over here at the side what they are.
Yes.
Now division is going to work in a very similar way. All we have to do is break them up, see what we've got, and reduce it down. Now, the i's are going to cancel just like an x. So an x over x, that would reduce down and go away. I's are going to be the same way. So all of these have been the same. They're all going to have the same directions, and they're all going to be simplified. All these were simplify. We're now going to look at this one. So let's say we have the square root of, how about a 27 times the square root of 14. And let's make that 14. Let's make that a negative underneath there. And let's put the square root of 7 down below. Now, all we have to do is break up all of our roots and reduce it down as much as we can. So 27. How does 27 break down? Well, 27 breaks down into 3 and what? 3 and 9. And we want perfect squares, so that's 3 and 3. Is it going to come out as an imaginary number? No. Why not? 27 was positive. So that breaks that down then into 3 square root of 3. What about 14? 14 is 2 and what? 7. So it's not going to break down at all. We will, however, though, have to bring out an I. And the 7 down below, that's not going to break up any either. So the only part that would break down at all is that square root of 27. Because 14 is 2 and 7, and there's no pairs. Now what we need to do is we need to clean it up as much as we can. So I'm going to work on the numerator, the top half first. And then I'm going to see how I can use that with the denominator. So let's go ahead and work on the numerator first. And then we'll focus on the denominator. Now on the numerator, what do we have? We have 3. Okay, that's out in front. We're going to put the I with it. And what about underneath the root? Well, what goes underneath the root is going to be 3 times 14, which is 42. And that's over the square root of 7. Is everyone comfortable with that part?
No.
Okay. So you see how I got to this step, right?
No. I'm just kidding.
Okay.
It's just all new.
Yes,
and
it is. It is. It's not difficult. You just have to be careful and think about it. And that's why I'm writing out what those pieces are. Now what we can do is just like when we multiply, the roots multiply. When we divide, everything below the roots or inside the roots will divide as well. So, when I rewrite it, my final answer is going to be 3i. Now, what's going to go inside of here? Well, what are my roots? 42 on the top, 7 down below, and see 42 divided by 7, well, that gives you then a 6. So that is my final, finished, completed answer. So it's going to be 3i square root of 6, because these two can go together. Why can they go together? Because they're both underneath that root. So all you have to remember is if it's inside a root, it can combine with another root. Multiplication multiplies, division divides. We'll do one more, and then we'll talk about standard form. Well, we may take a break after we do one more. We've been here quite a while.
Yeah,
Yep.
it's
Shoot
about-
right now.
And the next part's even easier than this. This is not difficult once you get the concept. I mean, there's not a lot to do. It's just basic
Breaking it
algebra, but
down.
it's new. That's the thing, is it's brand new. Okay, so let's try one more. How about okay, let's look at this one. See what we can do with this one. Well, first things first. Break up these roots as much as we can. So what about the square root of 16? That's a perfect square, so that is 4. It has a negative, right? So that negative here, that's going to come out as a I. What about 8? Well, 8 can be broken down, and that's going to be 2 and 4, and then 2 and 2. So that's going to come out as a 2. And I like to use parentheses, that way it's less confusing. So I have a 2. Now, because this is negative here, yep, now I can come out, and what's left over that we didn't have paired up? That 2 is still by itself, right? So it comes out as the square root of 2 underneath. Over the square root of 2. This one I think is actually a little bit easier, and it's the same question basically that you're going to get from your homework. Different numbers is all. So now let's clean up the top part. So 4 times 2. Okay, 4 times 2 makes it an 8. I squared, because that's I times I. Square root of 2 over the square root of 2. Is everyone okay with that?
Yeah, sure.
Okay, does it make sense what I did?
Yeah.
Because 4 times 2 makes it an 8. I times I makes it an I what? Squared. Now, just like an x, what do you notice on the top and the bottom of this fraction? So those, just like an x over x, they could cancel, right? So in this case, the 2 square root and the 2 square root down below, those can cancel. So that's going to now leave you with 8i squared. And from our previous definition, what do we know about I squared? Yep, I squared is a negative 1. So that means that this piece is going to come out to be negative 8 for your final answer. It's just a little bit of algebra.
You multiplied with
Okay.
4 times 2.
Right, so let's go
Because they're
through, yeah,
parentheses.
let's talk about this one real quick again. We've seen it. I'm going to go talk about each step, and we'll discuss where each step came from and where it goes. So we took the square root of 16, okay? The square root of 16 was 4. It had a negative underneath that radical, so that made it a 4i. Then we took the 8. 8 broke up into 2 and 4, 2 and 2, so we have a pair of 2's. That comes out. The negative makes it an I. And then what's left over that doesn't have anything? Square root of 2. Now, that square root of 2 just comes down because there's no other square roots in the numerator. And what do we have up here in the numerator? We have 4 times 2. Those came out. 4 times 2 makes it an 8. I times I makes it an I what? Squared. And then I looked and I saw, okay, this square root of 2 and this square root of 2, one's on the top, one's on the bottom. They cancel. So then that left you with an 8i squared. And we know that I squared is negative 1. So then the final part came out to be a negative 8i. Okay, so that's going to be your final answer, is simply negative 8i. We'll take a short break, and then we'll come back, and we'll look at standard form.